Good morning, welcome to our session here. I prepared some slides on creating COVID secure workplaces using active air purification technology. There's a number of slides that we have here. Sorry, I do apologize. We first have an analysis for existing guidelines for commercial buildings, and then I put some slides together to give an insight on how active purification can work and how it adds an extra layer of protection. And then I have some case studies at the back, and then we can also have a discussion on how it can create COVID safe workplaces. Okay, so firstly, just a discussion around the limitations of the current COVID mitigation. Presumably everybody will be familiar with the current guidance, which focuses on ventilation air change increases, which has been predominant since the pandemic started. Obviously, ventilation is an essential feature of all buildings, but when you increase ventilation air changes, that can bring with it unwanted consequences, which again, I presume that everybody's familiar with this, but I'll just run you through. Firstly, it can make rooms uncomfortably cold, which affects the productivity and health of the occupants. Similarly, it can increase the rate of pollution ingress from the outside, which has the same effect. And then also the fact that the guidance kind of advises that ventilation rates are increased and recirculation rates are reduced. These processes do affect the energy efficiency of a building. It will reduce the carbon footprint, increasing energy consumption and cost. And perhaps also, a very important point here is that increasing ventilation air change rates doesn't actually physically destroy viruses. Yes, it will increase the rate of dilution inside a space, but the current guidance kind of assumes that fresh air ventilation rates will just blow virus particles away. Actually, it can also, that's true, but it can also help viral particles spread in the same way that recirculation processes can help viral particles spread. Now, what we describe as active air purification, that's an equilibrium process, can safely avoid these consequences. Okay, so what do we mean by active air purification? So firstly, it's a process that basically mimics the processes that are constantly happening in the outside air, but immediately. So it's a completely non-chemical process, and it relies on the active particles produced by the process of ionized hydrogen or hydroperoxide molecules, basically created through the technology within products, and I'll showcase one manufacturer further down. But basically, ionized hydroperoxides are produced by a photocatalytic reaction from technology and also from ambient water vapor in the atmosphere. And those molecules are distributed out into the airspace. And that's basically what the process is. So it basically fills the indoor environment with the molecules that will be doing the purification. All right, so as a process, typically it's effective across all three categories, okay, of pollutants. So the microbials, so viruses and bacteria, which is obviously been the focus of this pandemic. This is where we want the greatest level of instant protection within indoor spaces. I'll talk about that further down, but also protection against things that come onto the air, so VOCs and odors and other gases, and finally particulate pollution. So how is it working in that the ionized hydrogen peroxide molecules will break down microbials basically through a process known as cell lysing, which destroys the plasma wall and exposes the DNA inside the cell. So that's really the process. It's exactly the same process, incidentally, as standard sort of disinfection. When you wipe a surface with Dettol, that's what's happening at the molecular level. So it's genuine disinfection as a process. Some technologies, like the one I'm going to showcase further down, also have a capability of agglomerating particulates that that come into the air, which as a combined effect is very, very good at removing particulates. One of the other key points about this type of method is that it treats both air and surfaces. So this is quite an important point. If you have some of the passive systems, they're typically only capable of dealing with one type, but this type of process is capable of dealing with pollution in the air and on surfaces simultaneously and continuously throughout the airspace. And that's quite important, again, in the context of the current pandemic with the SARS-CoV-2. I've underlined the point here that this technology has the ability of destroying viral particles instantly at the point of transmission. Okay, so that simply means if somebody comes into the room and sneezes and issue out the virus onto the air, well, it's the air itself that's doing the disinfection. So those viral particles are instantly treated and destroyed. So this technology is very unique in that regard compared to other technologies. And this is perhaps the most important feature in the context of the current pandemic. Other technologies rely on the viruses or other pollutants to be moved to the point of treatment or removal. The other points further down, this technology is not new. I've had people ask me a number of times recently about this. It's actually been used for a large number of years, so it's actually tried and tested and proven in the market. Very, very important point, this, because obviously so many new technologies have arrived on the market since the pandemic hit us, and everybody's claiming to be the best at removing SARS-CoV-2. And I think it's important that people look at the credentials of the technology itself and the manufacturer when they're considering options. As we said, it creates an environmental equilibrium effect, which creates an extra layer of protection in indoor spaces that's not dependent on the actions or behaviors of people. And ultimately, a technology like this will create a safer, and as I describe it, future-proofed environment. So why is it different? Kind of touched on this already, because it creates this equilibrium process throughout the indoor airspace. It has the ability of destroying pollutants, viruses, bacteria, odors at the point of transmission in a way that's not reliant on pollutants being moved to the point of removal, which is, of course, a key feature of passive technologies, okay, which include filtration. All of the UV product processes like upper room fire UV, all of these processes are subject to various limitations. The viruses have to be moved very close to them. That has to be static. There's line of sight issues with UVC, etc. So all of these points are grouped together into what we call passive air treatments. And the key difference is that none of these passive processes will provide instant real-time protection in the conditioned space, in the place where people are working. So when it comes from microbial emissions like viruses, this is the most important difference. Somebody can be in a room and sneeze out the virus, and you can have a UV system on the ceiling or a filter in the corner or something like that, and that virus will remain alive until it's moved close enough to those units to be treated. And this is where a lot of the misconception has come in the market in recent months over these technologies. A lot of people think they provide complete, comprehensive, real-time treatment when they simply don't. They can't, basically. So the key benefits of a technology like this: it stops the viral R rate increases throughout indoor environments. That's very, very important point to make. My company, we've been installing this sort of technology for a while. Many people that have installed it have tested the effect, and we have various metrics to show that its active effect is doing what we said. And obviously, the ability to stop R rate increases in indoor environments has been a key objective since we entered the pandemic. This technology will improve the indoor air quality, which ultimately can lead to improved health and well-being across the workforce. In healthcare settings, it reduces illnesses and acquired infections in hospitals, and absenteeism rates in any setting, which leads to improvements in productivity. Another key feature is the energy efficiency argument. There's no exposure, if you like, to increased energy costs when you use this technology. You can safely continue to use recirculation processes because you're getting that environmental protection throughout the entire airspace. There's no risk of the virus transmitting when you have a process like this running. And that means that the carbon footprint in all the buildings that you manage doesn't have to be negatively affected, as is negatively affected, I should say, as is the current case with the current mitigation measures. People are being told to increase ventilation rates, and we already discussed the consequences of those. A process like this also eliminates the need for recurrent fogging processes. If you may be familiar with those, some companies use vaporized hydrogen peroxide fogging to, recurrently, or once a month or something, cleaner an indoor space. We have some of our higher profile projects actually have shown that our technology eliminates the need completely to do fogging going further, because it's a continuous effect rather than a one-off effect, and the effect is just as effective. And of course, it's also working when the people are inside the space, which of course you don't have that benefit with fogging processes. So it creates this extra layer of protection, as we said before. It creates healthier environments. I think the point about building confidence for staff and customers is still important. When we first started talking to people about active treatments after the pandemic hit, last summer people were thinking that the whole problem would be gone away, and it was really a health issue at the time. But then it became more of an economic issue, and the idea of building confidence in staff has become more and more prevalent. So this is a very important point in this. And then the final point in this slide is the reduction of the potential for civil liability post-pandemic. I think this is essential too. In my view, as people prepare to go back to work, there's potential for civil cases. Somebody may come to work, they may feel that they might catch something at work, and then a company may end up in court. And I think it's going to be important for people to be able to argue that they've taken the best and the most effective possible measures, and to be able to demonstrate that to a court at some point further down the line. And when you can give explanations about how this technology or this type of technology works and its safety credentials and other things, and how it differs from HEPA and other filtration and UVC, which leave considerable risk for R rate increase, then you really are reducing to the maximum the potential for exposure in this area. Okay, so typical use cases, it's really any indoor space, so any commercial building, healthcare settings, schools. These types of technologies are used in emergency vehicles, they're used in supermarkets and across transportation systems, inside airplanes, you name it. There's all type of any type of indoor space it can be applied to. The manufacturer that I'm going to showcase in a few minutes makes a whole range of different products depending on the environment that's being treated. Okay, so I'll move on to the next slide. So the company that I'm showcasing in this presentation is RGF Environmental. They're an American manufacturer, been around for 35 years. It's their air purification technologies were invented 15 to 20 years ago, and they're used all around the world. So this slide describes the two processes, photohydroionization, and then a more advanced version of photohydroionization that they describe, or they call reflective electromagnetic energy. A bit of background with PHI. It was originally developed in the late 90s. RGF prior to that were offering air treatment processes, but using ozone. And in the sort of 90s, people started to really understand the health issues relating to ozone generation. And RGF wanted to produce a process that did not produce ozone. And that was created in the late 1990s. And it first came to prominence in the immediate aftermath of the 9/11 terrorist attacks in America. And just after that, the Department of Homeland Security put a project together to consider how to protect if a terrorist were to aerate a virus inside an airliner. Now, this is around about the time when people were worried about the anthrax scares. It made the news. I remember it quite well. Unfortunately, it's me showing my age, but some of you may well remember that as well. But basically, in that project, RGF was consulted by Sandia National Labs, and the idea was, look, we have a technology here that will allow the virus to be killed at the point of transmission within the cabin. Airliners at that time were using filtration just like they do today, but any filtration process is passive, as we've already said. So the virus can be issued into the air, and people will catch that virus before it reaches the filters. But when you have a technology like this running, the virus is killed before it gets there, and therefore you're offering the best possible protections to the people inside the cabin. So they were told, look, that sounds very interesting. Can you go away and prove it, please? So RGF went away and developed a experiment. They had to make a machine to simulate a human sneeze, and basically they did that. They then returned and proved the process back to the authorities. Now, 2 years after that, we had the SARS pandemic, and RGF's technology was adopted or used. It was acquired by the Chinese government for a number of public buildings in China. And I suppose the rest is history, so to speak. You have these. It's seen a steady increase in adoption in the years since then. Reflective electromagnetic energy is just a more advanced version of the photohydroionization process, but it does contain a separate process of ionization that RGF used purely for the capability of agglomerating particulates within the equilibrium process. Now, if any of you have been reading the recent press about ionization, technologies that offer ionization only, as opposed to ionization within an equilibrium process, must not be compared to this technology. They are mutually different, and the effect is very different. Ionization only technologies are actually more passive than they are active, as we're describing here. I won't say much more. I won't say any more about that at the moment, but just to make that distinction. Both of these two technologies are also patented. Now, to talk about safety, the RGF technology has been tested in numerous settings over 2 decades for both efficacy and safety. The next slide talks about the efficacy, but here, just to describe about the safety. So firstly, each of the products made by RGF are calibrated to produce an equilibrium concentration of the oxidizers, the ionized hydroperoxides, at 0.02 parts per million. Now, in terms of exposure limits, in the United Kingdom, we have the EH40 2005 workspace exposure of 1 part per million, so it's around about 2% of that. But I think most importantly, that sort of concentration is very similar to the concentrations that are constantly being produced in the outside air, and therefore it's completely safe for people to breathe. If you were to measure the typical concentration of these molecules in the outside air, it ranges from 0.01 to 0.056, depending on what sort of amount of sunshine we have and so on. And at these concentrations, there's no issue with safety. And in terms of ozone production, well, any photocatalytic process will produce some ozone. The only question mark is how much. And there's a lot of noise in the industry at the moment about products that produce ozone. Ultraviolet processes will produce ozone. I mean, all sorts of processes technologies are prone to producing trioxygen, as it's called, O3, ozone. The RGF technology, however, has been thoroughly tested against ozone production. There are various standards. The only jurisdiction in the world that's legislated against devices in terms of how much ozone they produce is the state of California. And ETL Intertek, which is the world's biggest testing company and a FTSE 100 listed company, they provide testing which is approved by the states in California for various devices, and they offer 2 programs. One which verifies against the mandatory limit, which is 0.05 parts per million. Yes, 0.0, excuse me, I'm going to get my figures wrong. Yeah, 0.05 parts per million, or 50 parts per billion is the mandatory standard. But they offer another test, which they call zero ozone, which basically is 1/10 of that, which is 5 parts per billion. RGF's technology was the world's first to be put through the zero ozone compliance from Intertek, and as you can see on the slide, it's achieved that. So again, way below the mandatory standards, less than 1/10 of the mandatory standards produced by the RGF technology is completely safe. And as I've said earlier, millions of installations, never been a safety issue with the RGF product, so it's completely safe for people to use, and you can have confidence of that in your buildings. So there's quite a few targets on this list. Just run through a few of them here. So firstly, and perhaps foremost, the SARS-CoV-2. Further down, I'll talk a little bit more about this, but RGF have done, since the pandemic hit, they've produced, and it's an ongoing process with RGF, they've produced a number of tests against both surface and aerosolized contaminations of SARS-CoV-2. And the results that they've achieved are really quite remarkable. 3.5 to 4+ log reduction on a continuous basis is really quite impressive. And when I talk about the aerosolized, we have a point further down, but I mentioned it now. The testing that was done by RGF for aerosolized SARS-CoV-2 was basically done in a very large chamber, 1,280 cubic feet in size, which, by the way, is bigger than the 1,008 cubic feet chamber sizes used to test the clean air delivery rate of passive filtration products. But anyway, 1,280 cubic feet is 8 foot by 8 foot by 20 feet. And what they did for the experiment is they located the unit inside the chamber, and then they put various collection plates at various points within that chamber. And the experiment was to aerosolize the virus. And in this experiment, they aerosolized the virus every 15 minutes, into that airspace. And then they took readings from the collection plates at various intervals over a 24-hour period. Now, the results showed that you had a 3.5 to 4+ log reduction, but everywhere throughout the 1,280 cubic foot chamber. So in other words, it's demonstrating that the effect is occurring and happening everywhere throughout the whole space. And that's the reason why that experiment was set up in that way, as opposed to just simply a in a tiny little chamber with a couple of collection plates looking at surface contamination. All right, so that's a theme of many of the RGF experiments down the years, because obviously how this technology works, it's very important for people to understand that you're creating an equilibrium effect, which to many people, that's a kind of new concept, because you don't get that. Passive technologies don't work in this way. Okay, so the other targets, H1N1, swine flu, I should say. The sneeze test proved a 99% reduction of all microbes coming out in a sneeze within 3 feet, so we call that the 3-foot exclusion zone. E. coli, listeria, strep, tuberculosis, bird flu, many others. We have RGF actually publish a list of all of the viruses and bacteria and basically other pollutants that have been tested by the many entities that have performed testing for them over the years. And that can be found on their website or on our website as well if people are interested. Okay, it's approved for the use in the US military. I think we mentioned that earlier. And there's various other, I don't want to read this for you all the way through, but you can see here that there's a host of testing and a host of use cases of the technology. This point further down here, I'll just highlight this as I can because I can't see the main screen. RGF claims that its technology produces 1 quadrillion ionized vaporized hydrogen peroxide molecules every second. Now, I make the point about this because it is quite important. There are what we call hydroxyl generator processes, again, some of which have started to be marketed since the pandemic. But I have not, as somebody who studies the market a lot, like I do, I've not seen any technologies that come anywhere near the volume of molecules produced in their processes. The closest I've seen is something that produces 100 billion or something like that. Compared to other technologies, there is a very big difference between that and the level produced by RGF, and also the ionizer technologies, which are way lower in this number. And this has a quite an important effect on the performance. This plus the longevity of the particles, the RGF molecules, because they're similar to the outside air, their longevity is quite long lasting, anything from 8 hours to 20 days. And that's really what is able to give the process its active effect throughout the airspace. With other technologies, the charging of a particle, for example, is only going to last for a few seconds, and therefore it will be gone before it's got anywhere. And it's the same thing with other technologies. Other hydroxyl generator technologies also are at risk of producing residues and things like this because of the particles that are being produced, highly reactive hydroxyl radical particles. All right, so this is an area that should be examined. If people are looking at alternatives in this area, very important, in my opinion, to look at the production credentials of the technology rather than sort of experimenting with new stuff. I mean, this RGF technology has been around for a long time. There are millions of installations around the world in over 60 countries. Never been an issue of safety, and the anecdotal feedback is always positive. So it's quite an important point. This, I appreciate that everybody's probably being bombarded with all sorts of information, but my advice in this area would be to do that. The people that I deal with, listen to this. It's I think it's a very important point. Okay, so move down to the next one. Kind of mentioned this already. RGF built this unique sneeze machine, which produced a 99% kill rate within 3 feet. We've already described there the innovative bioanalysis testing. That's a company that they used to achieve the results with the SARS-CoV-2. And as you can see again, the testing that's been performed over the years by various governments as well as testing bodies. So it comes to the market, it comes to you with very, very strong production credentials. Okay, just one final point, the norovirus and MRSA protection. This is a very important point in the US. If any of you deal in the hospitality sector and also in the cruise sector too, RGF's products are used by some of the biggest cruise shipping companies in the world, and also some of the some very well-known restaurant franchise businesses in North America. One of which is TGI Fridays, another one is Chipotle, where their technology firstly has been rolled out in all of their restaurants, but secondly, in the case of Chipotle, the RGF technology forms part of their food safety compliance program. So it's used not only in the restaurants, but in the food preparation spaces as well. RGF's technology is used in all sorts of food preparation and food processing facilities, as well as obviously places where people do work and where customers spend time. Okay. There's a slide here about how simple really this sort of technology is. I think the key theme with this is that the products produced by companies like RGF and others too are designed for simple and easy specification and retrofit. Okay, so obviously in the case of the pandemic, in the case of where somebody wants to improve the indoor air quality within a space, if you have a technology that's easy, simple, scalable, and can easily be installed, then it's seen as a benefit in itself. Okay, just to give you a quick example, we we specified and installed in a 10-story building in central London, and the whole project from beginning to end was done in 3 weeks. That was incidentally where we had to bring the products in from the US as well. So it's a very, very simple process. So the various steps are quite simply, we review the building plans and the HVAC drawings. So my company, we have that expertise. We just receive the information from our our customer. That allows us to understand the HVAC strategy for a space. So I've seen buildings like the Lloyd's building, for example, which obviously is a comprehensive HVAC infrastructure throughout. And I've seen other buildings like old warehouses, barn spaces, even some buildings that rely on natural background ventilation as opposed to ducted supply. Understanding the HVAC strategy of the space that you're treating simply points you to which products need to be used. In general, for buildings, it's going to be a combination of standalone units or in duct units, just depending on what we find. In the case of RGF, the inducts are based, the number of units required are based on the airflows at the floors and also at the AHUs. And when it comes to standalones, we treat based on floor area and volume, and also occupancy type. And then obviously we just plan the installation from there. Okay. And just a couple of examples of work that we've done here in the last 12 months. We have a number of intermediary relationships that basically have their own business. Obviously, they sell they offer our products as part of their own business. One of which is you can see here at the top, Chapman Ventilation is a company that specialises in hospitality. We've seen our units installed in a number of their customers in restaurant businesses in and around London. Some of our own projects, I mentioned earlier, Lloyd's of London. So perhaps one of the most high-profile projects we've done is our units, our REMI Halo LED units are installed throughout. Right now, they're installed and running throughout the iconic Lloyd's building in the City of London, which is a big achievement for us and for them, I might add as well. It's a great project that. we first started speaking with Lloyds very soon after the first lockdown was announced about a year ago. So, I'm very, very pleased and delighted to be working and supporting that fantastic building. Mishcon is a well-known legal firm. We've treated their head office as well. Again, with similar units, and then there's various other solutions we've provided. These are just a selection of companies. EcoFilters is a Midlands-based company that has many customers, many facility manager customers. Some of you may know that company. MGP and ITW are separate businesses, and then the two further down, Aura and Eden, are two of our intermediary relationships. And then further down, Dental, Domestic. These are projects that we've undertaken. Right at the bottom, Let's Pretend is a child daycare centre where we provided not only a solution for active air treatment, but also a ventilation improvement solution. That was quite important for them. They wanted to offer their staff and customers the best possible protections, and we're having more discussions with those sorts of organisations at the moment. Kind of ties in with the domestic offer. Okay, I've got a slide here, which just gives a little bit of data about the Lloyds and Mishcon projects. And it's a shame I can't blow this up, but I'll just explain this for you briefly. So I mentioned earlier about when we undertake a large project, we're quite happy and quite open to companies that want to do their own testing. So in the case of the Lloyds of London project, they wanted to test an entire floor before they rolled out, and each floor in that building is about 4,600 square meters. So how that works in the case of Lloyds is we basically simulated a production install, put the units in, and they wanted 2 independent tests, and the metric they wanted to use was the ATP metric, which is because Lloyds were doing fogging incidentally before that. They're very familiar with that metric. It's used by cleaning companies to basically determine and tell the customer how clean a surface is. And with our process, because it accelerates the rate of natural decay of cellular debris on a surface, I was able to advise that the ATP test in an office environment would be probably quite a decent test, because compared to a once in a month fogging process, you'd see a gradual increase of the organic loading on a surface over a month, whereas with our process, it goes down and it stays down because it's continuous. And that's basically what the results showed. So that, in other words, because you're getting an increase in the organic loading month on month, because you're not getting continuous protection, the fact that the levels were reduced and then they stayed low was evidence enough for the project to basically be rolled out for this building and other buildings within the network. And this slide shows some of the levels of reduction, but you can see here a 97% reduction in 7 test areas over 3 weeks is pretty remarkable. Now, in the case of Mishcon de Reya's Africa House head office, which is just a few steps down from Holborn Station in central London, what happened in this instance is we installed the units and then the testing started afterwards rather than prior. But the testing in the case of Mishcon was much more comprehensive. It was actually 35 swab locations, but the results were the same. You can see here an average of 66% reduction, in 1 week. Basically, the testing in the case of Mishcon de Reya went on for about 7 or 8 weeks. It may well still be going on now. I've seen the results for a couple of months. And basically, it was very similar to Lloyds. You had a very rapid initial reduction, and then those levels were kind of like sustained over the time. And I think quite importantly in this instance, the occupancy of this building was about 30%. In the case of Lloyds, it was skeleton staff when we did that testing. But in the case of Mishcon de Reya, the building was basically 30% occupied when we started doing that testing. And that's quite important because when you're testing ATP, if you've got a high volume touch point like a keyboard or a door handle or something, then the rate of deposit can sometimes actually be higher than the rate of decay. So there are some times where the level goes up, but because of the accelerated rate of destruction, the overall figures get down and stay down, basically, and that's what the testing showed. So my general message to people considering this type of technology is to make sure that it's doing what you expect it to do, but also be very, very careful about the type of testing that you're doing. I've been asked in the past about, look, we want to see what's happening in the air. Well, that's unless you're swabbing the air itself. We have devices that can, you can walk around and swab the air, but that's only going to show you a bacterial type of contamination. When it comes to viruses, the only way to really test that is to make up your own experiment. There are no protocols out there, and therefore the costs can be very, very high. Because this technology is working on both surfaces and in the air, I always ask people to really consider the value of the testing performed by RGF in the aerosolized sense from SARS-CoV-2, because it's unique in the world. Doesn't have any equivalent in public health or any other research body that we know about in terms of the 1,280 foot cubic foot continuous effect. Okay, so again, just to summarize this, testing I think is important. We welcome it, and obviously you should really make sure that whatever your process is, it's doing what you expect. There's been a number of technologies in recent weeks that have been found out in this area. And it's a good thing, because obviously ultimately we're talking about the health of people coming to work, and there's all sorts of implications with that. Okay, so I'm nearly done. 2 more slides here. Finally, or penultimately, I've given a couple of other use cases. Now, RGF basically publish a project that they're aware of pretty much once a day these days. But just to give you some idea, in the sectors schools, healthcare, mass transit, emergency services, commercial, leisure, hospitality, you name it, they're installing everywhere. This is a very big one. Fisher Brothers, this was announced back in February, I think, 8 million square feet of sort of skyscraper accommodation, combination of residential and commercial, all managed by this one company. You've got the Cayman Islands Health Authority, you've got various mass transit systems, as well as obviously schools and healthcare and hospitality venues. As you can see, leisure venues too. As you can see, the adaptability of the technology is there. RGF make products for all sorts of different purposes, and you can see that there are some pretty large scale projects detailed here. Now, all of that's available online if anybody's interested. And then finally, just to not to reiterate, just a few points about RGF, because it really is a serious business. They make at the moment over 500 products. They cover 3 verticals: air and water purification, food, sanitation. Been around for 35 years. They're currently holding 32 active patents, over 700 staff. That's probably gone up since I wrote this slide a couple of months ago. They've made enormous investments in new production facilities in the last 12 months. So basically, when the pandemic hit back in March last year, RGF was hit by a sort of metaphorical tsunami, and they had to respond very quickly in order to deal with the order flow that they were receiving from all around the world. So they quickly made a decision to make, to basically produce some new production facilities in West Palm Beach and north of Tampa. Those facilities are now online. So RGF's method of distribution prior was basically to work and produce products to order, which is a great way of doing it. Obviously, as long as you can deal with the scale when the spikes in demand when you need to. And these new investments mean that RGF can now deal with a much greater demand capacity, which is obviously quite important, I think, for us. We've been able to leverage that recently, and it really does work. So I mentioned they have a global distribution network, 60 countries. They've seen an enormous sales growth, as I said, this year, and that is still growing instantly. And then finally, last year, RGF was designated by the Department of Homeland Security as a COVID critical manufacturer in the production. In the context of this, is in the production of equipment used by first responders in North America. But again, it's worth mentioning that because obviously RGF has been involved in various government initiatives going back 20 years. And I think this is a very important credential. They really are a very significant manufacturer of environmental products and innovation over their entire 35-year history. I mentioned earlier, my company's Better Indoors. The company behind that is called Healthy Indoor Environments, and we are RGF's exclusive distributor here in the UK and Northern Ireland. Okay, so thank you very much for listening. I'm just going to go back to here and just stop sharing that. Second, stop sharing there. I'm going to go across to managing. Okay. I've got, does anybody have any questions for me at the moment? Can't see any questions coming up. Let's have a look. All right. Okay. Well, if there's no questions, okay, thanks very much then. I will close off the seminar. Thank you for your time, and hopefully we'll speak soon. Thank you.